Thank you very much for the opportunity to give this presentation at the Sino Nordic Sustainable Development and Innovation Forum. My name is Torbjørn Larsen. I'm a research director at NIVA, the Norwegian Institute for Water Research. NIVA is a leading national institute in Norway for applied research on marine and freshwater environments. We conduct a wide array of research and advisory services related to environment, climate, and natural resources. NIVA's expertise is multidisciplinary with a broad scientific scope, and we work at international, national, and local levels. Both NIVA and I personally have been involved in cooperation with China and in China for more than 25 years. We have collaborated on a range of topics related to pollution, water resources, and the aquatic environment. We also opened a daughter company in Beijing 3 years ago. Over the last 25 years, there have been big changes in regards of environmental pollution and sustainability. Over these 20 years, there have been improvements on some issues and worsening on others. On the positive side, we have, for instance, seen decreased concentrations of sulfur dioxide in the atmosphere or decreased level of phosphate in rivers and lakes. In other areas, the situation has become worse. One of the most visible may be plastic pollution and marine litter that currently receive a lot of attention. The most serious and most difficult to tackle is probably climate change, with its wide-ranging implications for so many aspects for life on Earth. The World Economic Forum has for 15 years now published an annual global risk report. Here we can follow how the perception of big global risks has changed among a diverse group of stakeholders. The green colors represent environmental risk, blue economic risk, red social, purple technological, and orange geopolitical issues. There is a clear trend towards increasing attention to the environmental risks. For instance, while in 2007 the top 5 perceived risks in terms of likelihood was related to infrastructure, disease, and economic issues, in 2020 they were all related to environmental issues. I must note here that the survey was made before the COVID-19 pandemic became global, so it would probably have looked quite a bit different if it had been taken up just today. One gets pessimistic when listing all these challenges. But of course, they also give a lot of opportunity. A key part of the solution to many of today's environmental challenges is innovation. That can be innovative technologies to remove all pollution, to stop the releases of pollutants, or to produce products with much lower pollution in the first place. But it may also be innovations that help identify, manage, and reduce risks, ways to rebuild nature where it has been damaged or lost, or ways to help policymakers, industries, or the general population making greener choices in their daily lives. I will continue the presentation with giving some examples of promising developments and innovations that can contribute to sustainable development of the environment with focus on marine and freshwater environments. Let us start with the issue of marine litter, microplastics, and plastic pollution. The topic has received tremendous attention worldwide the last few years. The issue is not actually new, but with the fast growth in use and hence disposal of plastic, it has become more and more severe. The challenge is complex as it is a global issue linked with an enormous amount of different industries and businesses, as well as almost every single one of us human beings. There is need for technology development and infrastructure investments, but also changes in the behavior of us consumers. There are many knowledge gaps regarding plastics in the environment, gaps that need to be filled before we can find the ultimate holistic solutions. For instance, we have little historic data. There have been no plastics in environmental monitoring programs. We know too little about the most important sources, and we know too little about the effects. However, we already know enough to do something, as we know that our growing use of plastic generates an increasing amount of waste that in turn needs to be collected and treated in order not to become pollution. One example of China's recent efforts to tackle the plastic pollution challenge is the demonstration program of zero waste cities. Here, 11 pilot cities and 5 pilot cases are identified to test policy, management and technology options to dramatically reduce their waste generation for different types of waste. If successful, this will of course contribute to reduced plastic pollution. But to what extent and what will be the effect? What are the most cost-efficient measures? In order to answer such questions, we are developing model tools that links the implementation of measures to the impacts in terms of environmental pollution. We can model what type of measures are having the most effect in terms of reducing the pollution, based on the local socio-economic and nature-given conditions. We will start with the river catchment. Inside, there are different activities, for instance, aquaculture, agriculture, daily activities from urban populations, waste dumps, hotel and fishing villages. They all contribute with a certain profile of plastic pollution that may be washed away with rainfall and be transported with the rivers to the ocean. With the model, we can then assess what pollution reduction measures are the most efficient and also include the costs and the socio-economic impacts. For the operation of such a model to be any reliable, of course, we need local knowledge and data. This brings me to the next example, environmental monitoring. Environmental monitoring is an important part of implementing measures for improving the environmental status. If there is no monitoring, we won't know if the measures actually works. I like the phrase, what gets measured gets managed. It's taken from business management, but I think it works better for environmental management. If you measure the state of the environment and observe how it changes over time, then that helps in prioritizing measures. We must, however, remember that it can be difficult to monitor what actually matters, and that all we can measure not necessarily is important. This may sound philosophical, but it's very practical, and I'll show you a couple of examples. One is about how water monitoring in Europe changed from only measuring concentrations of chemical compounds in water to measuring biological indicators of ecosystem health. The other example is about using new monitoring platforms and using data in new ways. First, to the example of monitoring ecosystem health. In Europe, we have seen a paradigm shift over the last decade or so, where we try to monitor the health status of the aquatic ecosystem. Before, we measured, for instance, the water concentration of phosphorus or the absorbance at a certain wavelength, of course as proxies for nutrient richness or algae concentrations, but it didn't actually necessarily tell how much or how was the ecosystem health. With the establishment of the European Water Framework Directive, a set of biological indicators were established in order to better be able to monitor the ecosystem health. It is still very simple compared to the complexity of nature, but it gives a much better picture of the ecological status. In environmental monitoring, we have always been looking for indicators that can be measured as proxies for something else, for instance, an undesired effect on the ecosystem. For instance, we measure the concentration of phosphorus or nitrogen as an indicator of the risk for eutrophication or algal blooms. The same type of thinking can be used in modernizing current systems for environmental monitoring. We can utilize smart monitoring platforms, for instance, unmanned boats or buoys, or use route-going ships instead of sending people and dedicated equipment on cruises or sampling missions. The use of sensors placed on such platforms can be used in combination with other types of data, for instance, from remote sensing to give close to real-time monitoring data for a fraction of the cost of manual operations. We are also developing sensor-based monitoring systems where we can use artificial intelligence to learn the system to see patterns in the data signals that indicate abnormal or abrupt changes. This can be used in early warning systems, for instance in water reservoirs, rivers, lakes or aquaculture units. The topic I will talk about next is nature-based solutions and restoration of ecosystems. Traditionally, solutions to environmental challenges have often been seen as technology inventions that can, for instance, treat polluted water or change an industrial process to pollute less. To stop and reverse the decline in biodiversity, we not only need to protect existing ecosystems, but also rebuild damaged nature. To restore ecosystems is a way to reach political goals on biodiversity, for instance, under the International Convention on Biological Diversity or the European Water Framework Directive. But it is also a way to reinstate and promote important ecosystem services. Nature-based solutions have also become an important element of increasing resilience to climate change. It is, for instance, an obvious solution to reduce the impacts of extreme rainfall events in the future. On the pictures you see some examples from restoration projects in Norway and Europe. There are examples of restoration of marine habitats in a large European research project called MERSIS, where my colleagues from NIVA had important roles. The concrete structure on the picture is artificial reefs before being installed at the sea bottom. And the movie at the bottom illustrates the importance of wetlands and designated floodplain areas to reduce the impacts of floods. The global seafood consumption has been steadily increasing for many decades and are predicted to continue to grow. The total seafood capture, that means from wild stock, has however not increased much since 1990, meaning that the entire increase has come from aquaculture. Aquaculture may have severe impacts on the surrounding environment, so sustainability is key for this industry in the future. In China, development in seafood production and aquaculture has been developing very fast. The figure shows the growth in seafood production since 1950 and the share of production from fisheries versus aquaculture. Most of the growth has come from aquaculture, both freshwater and marine. Sustainability is key to further growth. Norway has long experience with aquaculture development, and NIVA has tools to help guiding both the industry and policymakers in how to develop in more sustainable directions. This can be everything from simple test kits for water quality in hatcheries to opportunity mapping for blue growth in coastal communities. Another bio-based opportunity for sustainable growth is algae-based bioremediation technology. NIVA has, since its establishment more than 60 years ago, developed a large culture collection of microalgae. Traditionally, the culture collection has mostly been used for academic research, but we are now building a pilot-scale facility for testing industrial applications of algae-based bioremediation. Algae can, for instance, be used for removal of nutrients and other pollutants from wastewater, from aquaculture, agriculture, domestic or industry sources. At the same time as removing the unwanted compounds from waste streams, they are refined by the algae and can be used for different products such as feed, food, fertilizers, or even high-value special bioproducts. For us, this is an important contribution toward development of a circular, bio-based and blue-green economy. I'm coming towards the end of my presentation. I have been talking about examples of opportunities for sustainable development of marine and freshwater environments using different types of technology and knowledge. These are key elements of sustainable development, but I also want to highlight the need for involvement of people with all sorts of roles in the society. If we give the impression that it all can be solved with technologies, it will be a failure. People's behavior, consumption patterns, and perception of opportunities and challenges are also important. Outreach and capacity building among key stakeholders as well as the general population is important. In order to meet the Sustainable Development Goals, social, environmental and economic aspects must be integrated. It is only when these three aspects overlap and pull in the same direction successful sustainable development can be achieved. I hope I have managed to show some examples where economic and societal development can be consistent with environmental sustainability. So thanks again for the opportunity to speak here, and thank you for the attention.